Okay, so let's finish up topic 8.2. So topic 8.2, we've been centered around heat and the transfer of heat. But how do we transfer heat? Kind of like in a house, right? We all have a heating system. We have HVAC systems. How does that HVAC really work, right? And so this is like an area where physics does help you be an informed consumer, right? So equally as interesting as the effects of transfer on a system are the methods by which this occurs. Okay, and there's three methods. Okay, the first one is what we call conduction. Right, so conduction is the heat transfer through stationary matter by physical contact. So if you look at our picture, as our flame is going here, it's touching this surface, and so that's going to transfer, right, the energy from the fire in the fireplace to this material, and so you're going to get like a heating effect on the floor, okay, because it's in direct contact with the floor. Okay, that's the main thing, is that there's physical contact. So if I take my hand and put it on a table, I am transferring heat from my hot hand to the table by direct contact. Okay, or you can also see another example would be if I'm heating, right? If I have, boiling water, or if I have water on a stove, the flame here is in direct contact, right, with the pan, which means it's going to transfer energy into the pan, but then the pan is going to transfer energy into the water. Okay, so you have two kind of heat transfer by conduction there. The next one is what we call convection. Okay, most ovens nowadays are called convection ovens, right? Because it uses what are called convection currents, okay, to heat. And so, and the same thing happens in water. But if I go back to my house example here, so as the heat, right, from the flame, what do they say? Heat rises. Okay, and so this is a process, right? The heat is going to go up out the chimney, and what happens is it's going to lose energy, and it's going to cool, and then it's going to just come back in. And you can see kind of over here on the side, right? The cold air is going to come in, right, and just create this continual loop, right? This continual loop is what we call a convection current. Okay, same thing happens with water. So the particles down here at the bottom are going to start getting warmer, and what do we say? Heat rises. So as the heat rises, it's going to lose energy, and then it's going to cool. But what does cold air do? It's heavier, it sinks. So what does it do? As it's dropping down, right, again, then we go back into heating and cooling. And so what happens is there's this continual flow of all this happening, right? A convection current. It's also the reason why you have weather systems, right? Especially like at the beach. So there's a reason why the wind blows one direction during the day and the other direction during the night, because where is it hottest, right, versus where is it coolest, and the wind is going to blow in that direction. Okay, and then the last way of heat transfer is what we call radiation. Now this is not radiation like nuclear radiation, right? So this is like emitting electromagnetic waves or heat into a room, right? So think about radiators, right? And if you have an old house, right, those big metal things that sit in the corner of the room where all the heat comes out of. I can remember growing up, one of the houses we lived in had these metal radiators. So there was just like a continual flow of hot water going through them. The water heated up the metal then radiated, right? That's why they're called radiators, the heat into the room, okay? And they got hot, right? And I slept next to one, and I really put myself up against the wall because I didn't want to be near the radiator because I didn't want to burn myself, okay? And then the other obvious example is how the earth is heated by the sun, right? And so the sun's going to radiate out. Here's the earth, right? It's going to come in. I'm not going to get into a debate about greenhouse and global warming, but I'm just saying that's how, right, the Earth is heated. Okay. All right. So Unit 8.3 or Topic 8.3 is going to be look at thermodynamics and heat engines. The good thing about the 2020-2021 school year, so the one that these videos are made for, these students do not have to worry about this section. Okay. But eventually I will make the videos for this topic so that I do have them for future classes. Okay.